Good afternoon, Wolfpack, and welcome to lesson 1.9, Proofs About Angles. Let's jump right in. I'm going to do a little bit of this with you for homework, but the rest of it I'm going to do in class together because proofs are a little bit of a different beast to tackle in geometry. So we're still talking about how theorems can help us prove problems. So let's work on our vocabulary first. Conjecture. A conjecture is a conclusion that is believed to be true. We use reasoning to show or to prove, where proof comes in, to prove that a conjecture is true. So in your science class, you probably talked about deductive reasoning. And deductive reasoning is the process of using logic to draw conclusions. For example, if I were to say all men are mortal, that means all men die. All men are mortal. Harold is a man, therefore Harold is mortal. Okay? So all men are mortal, Harold is a man, so Harold is a man Harold is a man, which means he is mortal because all men are mortal. A counterexample is an example that shows a conjecture to be false. And when we use a counterexample to say, oh, that's not true. A conditional statement is a statement that can be written in the form if P then Q, where P is the hypothesis and Q is the conclusion. Again, these should be terms that you're familiar with from science. For example, if two angles are supplementary, then their sum is 180 degrees. That's a conditional statement. The two angles, if they are supplementary, then what happens? Well, their sum is 180 degrees. So here's some properties of equalities, and these are pretty logical. The addition property of equality says that if A equals B, then A plus C equals B plus C. I can add C to both sides, and those two sides of the equation stay the same. The subtraction property of equality is the same thing, but I can subtract C from both sides. I'm subtracting the same thing from both sides, and the two sides of the equation stay the same. Notice subtraction property means you are subtracting. The multiplication property is the same exact thing, except I'm going to multiply by C and multiply by C, and the two sides of the equations stay the same. Division property says if A equals B and C is not 0, then I can divide both sides by C and end up still with the same answer. The reflexive property says simply that A equals A. We will use this a lot. It simply means that something is equal to itself, which I know sounds kind of ridiculous to even state, but that's what the reflexive property is. The symmetric property of equality says if A equals B, then B equals A. You see me do this a lot. I might write 53 equals X, and then I rewrite it as X equals 53. I'm just switching sides. Switching the sides of the equations. Everything maintains the same value though. The transitive property says if A equals B and B equals C, then A equals C. Basically, we cut out that middleman. Okay? A is also equal to C. Distributive property is distributing a value to two terms or multiple terms. We distribute a lot, so when we're distributing, it's called the distributive property. The substitution property says if A equals B, then I can use B in any expression for the letter A instead. It's kind of like the transitive property, and almost always you can use those properties interchangeably, but they technically are two different properties. So, let's work out an example using these properties. Use a postulate or theorem to find the value of X. This is kind of like a proof, but we're just listing the steps of why we're allowed to do this. So they give us that the measure of angle RST, the whole angle, is equal to 15x minus 10. Okay? So the first line of our proof says that the measure of angle RST, which is our whole angle, is equal to RSP plus PST. Well, how do we know that to be true? What makes that true? It's true because of the angle addition postulate, which is something that we learned quite a few lessons ago. If I add two angles together, they make a whole angle. And then, instead of the measure of angle RST, they have in 15x minus 10. Instead of the measure of angle RSP, they put in x plus 25. And instead of the measure of angle PST, they put in 5x plus 10. Why are we allowed to do that? What property? Look back up at your properties. What property tells us we're allowed to do that? The property would be the substitution. Substitution. There we go. Property of equality. Okay, I'm putting an equal sign for equality because I'm going to run out of room. So then what happens on the next step? Well, the next step, 15x minus 10 stayed the same, but they did x plus 5x became 6x, and 25 plus 10 became 35. What kind of math did they do? Well, they added x plus 5x and 25 plus 10. So that was the addition property of equality. Okay? You're just basically telling it what it did. Look at your next step. What did they do? The 6x, okay? They subtracted 6x from both sides to get 9x. So that would be the subtraction property of equality. Next step, 9x equals 45. Well, what'd they do to get 9x by itself? They added 10 to both sides. So we're back to the addition property. Of equality. So now they're right here at 9x equals 45, and we want to get x by itself. What are they going to have to do to get x by itself? Well, in order to get x by itself, they have to divide both sides by 9. So now we have the division property of equality. So each step, you're basically saying why this is so, why it's allowed to happen. The first step, right here, we are allowed to add those two angles because of the angle addition postulate. The second step, we were allowed to substitute in numbers because of the substitution property. The next step, it looks like this because we added things together, and we subtracted things, and so on. So those are the properties or postulates of why we are allowed to do things. Basically, you're just kind of having to state your case. Explain why you are allowed to do something. Now we're going to go and stop right there. We will do the backside in class together. Please make sure your homework is done completely, and I will see you next class. Have a great day, Wolfpack.